Ultrasonic, 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 dee-doo, 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 ultrasonic.
What's up, fellow LEGO lovers? Cameron Schreiner here from Georgia Tech, and welcome back to La BAM! In today's episode, we're going over the ultrasonic sensors programming. I'm going to give you some basic code to help you understand how this thing works on the computer, as well as show you a practical use in competition. So grab a robot with an ultrasonic sensor, grab a computer as well, and let's get started. Okay. So once you have LEGO Mindstorm open, let's start a program. Ultrasonic, dee-doo. Okay, so we're going to build a very simple program. We're going to have our robot drive forward forever until the ultrasonic sensor sees a wall. When it sees a wall, it's going to stop. Now, the first things I'm going to do is I'm going to pull in a switch case. This is our robot's decision-making factor. And I'm going to change the sensor to ultrasonic. Now, my ultrasonic sensor is plugged into port 4. Remember, it doesn't have to be plugged into port 4, but if you changed it, remember to change it on the programming as well. Now for the compare section. This is measuring distance, and it can do either inches or centimeters. Now, what this does is that if I have it at a less than setting, whatever this number is, let's say 10 inches, my robot will keep initiating its command and it won't switch over until it senses a distance less than 10 inches. And you can flip this around and it'll keep going until it sees a distance greater than 10 inches in this case. We're going to keep it on less than because I'm going to be looking for a wall that's getting closer and closer. Now I have to figure out if this number is good enough. If you see on the top of my robot, the ultrasonic sensor is mounted towards the back, which means the entire front end of the robot is sticking in front of the ultrasonic sensor, and that's about 7 inches. So if I changed this number to, let's say, 3 inches, my robot would keep running into the wall and it would never see the wall because the front of the robot is further away than 3 inches from the ultrasonic sensor. So at minimum, I would have to put 7 inches. But that also means that my robot would be running into the wall. So let's give my robot a little bit of breathing room. And I'll put it back to 10 inches like I had before. So that means it should stop about 2 to 3 inches from the wall. So now, if you notice, this is a switch case. So it has a mountain side and a flower side for the ultrasonic. So everything on the bottom with the mountains is what it does if it's greater than 10 inches. And if that basically means that I'm not near the wall. So if that happens, I want my robot to be driving forward forever. Set the power to like 50. Forward, B and C and straight. Cool. Now, the flower is what happens when it sees something closer than 10 inches. And for this program, I just want my robot to stop. Now, this is a switch case, which means it's only going to run this once right now. But I want it to make this decision forever, and so that way it keeps driving until it sees the wall. So I'm going to put a loop in front of my switch case, and once my computer loads, I'm going to then move my switch case into the loop, and now we're good to go. So let me turn on my robot. Ba-na-na-na-na. And I'm going to download this program, and let's see how it works. Wait for it to compile. Ding. Oh, I was a little early. Okay, let's see how this program works. It's time for an ultrasonic extravaganza. Let's see how that program runs. So, if you notice, I have my robot set to run the ultrasonic program, and what it should do is it should drive forward forever until it senses my wall, which in this case is a Lego box. So, I'm going to go ahead and run it. And if you noticed, the robot stopped before my wall. Now, I said it would stop like 2 to 3 inches from the wall. And if you notice, this distance is a lot larger than 2 to 3 inches. But the thing is according to the ultrasonic sensor, it's not. If we follow the ultrasonic sensor to the wall, so it hits about here. And if I go straight down from this point, you'll notice that that distance is about 2 to 3 inches from the front of my robot. So this is just another way to show you that the ultrasonic sensor takes some careful thinking, because this wall is slanted and your game object pieces may not be straight up and down. Now, to show you how the ultrasonic sensor can mess up, I'm going to put my hand right in front of the sensor. Now, if you notice, my robot started driving forward, and that's because of that same issue I said before. If your object is too close to the sensor, it can't get a proper reading. So just be careful when you're programming the ultrasonic to make sure that it works the way you want it to. It may take some finagling. So as you saw, the ultrasonic sensor can be useful in competition, especially if you need your robot to just continuously move until it hits a game piece. Just remember that it takes some very careful programming. So judge your distances right and try it a few times to make sure it stops where you want it to. And also, I wouldn't suggest it for making very, very small, finite adjustments. Use it to just get to a certain part of the field or get to a general location. So thanks for watching, and I look forward to seeing you in my next video.
Ultrasonic, 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 ultrasonic.